right? What features is the interviewer looking for? You have to build that solution. And while building the solution, you just don't have to build the solution. You have to deep dive into the difficult parts so that you can showcase your skills. Yes, you have to impress the interviewer. You have to show that you are a good designer, that you can design complex architectures. All right? So this is a very, very challenging task. This is an extremely challenging task, especially when it is time bound. Okay? If you just try to approach a design problem, if you just go to the interview with no preparation and you just try to approach the design problem from the top of your head, most likely you will fail because you won't even know where to start. Okay? So today's master class is all about this. When you go to an interview and you are given a design round and you have never been through a design round, then how do you start approaching the design round? And the aim for us is to maximize our chances of getting selected, right? The aim is for us to maximize the chances of clearing the interview. So what approach should we follow to clear the interview? Is that clear? Is the purpose of today's masterclass clear? The agenda of today's masterclass. Then how do you start approaching the design round? So throughout the masterclass, today we will learn a 5-step design process approach. Okay? First of all, we will understand what the problem statement is, what the functional requirements are, what the non-functional requirements are, and we will try to estimate the scale. Once we are done with that, then we will go ahead and we'll understand the system. Aim for us is to maximize our chances of getting selected. Right? This is what we are going to discuss in today's class. In an actual interview, in the last 15 minutes, so the interview is of 45 minutes, but in the last 15 minutes, you might also dive into advanced questions. Okay? And to demonstrate this approach, to demonstrate this 5-step approach in today's class, we are going to pick a toy problem. Right? We are going to do the high-level design of a system called a type head system. Is that clear? Yes or no? Perfect. Now, for those of you who are not familiar with what high-level design is, because I know that there's a lot of people in the chat here who have never heard of this thing called system design, this thing called high-level design. So let me quickly tell you what high-level design is. All right. Let's suppose you are building a chat application for your friends. And let's say you have 5 close friends. And you're building the chat application for them. If you're building this chat application for them, then will you buy millions of servers? Will you go ahead and purchase millions of servers? Will you set up something in the cloud? Will you try to be very careful about the security? Will you choose a fancy database structure? None of those things, right? Versus, if you're building the app for, let's say, 2 billion people. If you're building the app at that scale, then the design will completely change. Don't you agree with this? The design will completely change if you build the app for 2 billion people, right? So, system design, the subject of system design, and especially high-level design, it deals with this. It tries to figure out what challenges occur as you scale from, let's say, 100 users to 1 billion users. So what unique challenges occur in the first place? And how do you solve those challenges? Right? What are the common patterns? Right? What are the common patterns and solutions for handling these challenges? That is what high-level design is about. So in today's class, we will discuss the high-level design HLD of type head. And don't worry, if you're not familiar with what type head is, I will explain what type head is. I will explain what the idea of type head is. Okay? So we will study we will discuss the HLD of type head. Just a heads up, we will not be writing any code. Okay? We will not be deploying systems. And we will not be building apps. We will have a discussion on the infrastructure, on the scaling. How do you scale the system up? What kind of database should you choose? How do you cache the system? That is the kind of discussion that we will have today. Alright? Now, if you have never had this kind of discussion, doesn't matter. If you have never had this kind of discussion, you can still enjoy today's class. So just sit back and watch this like a movie. Alright? Like an educational movie, like a documentary. Fair enough? So let's begin with that class. Just a heads up, folks. There's a bunch of questions that are there in the chat. For example, someone is asking, I want to know about the curriculum.
Hello.
And there's a bunch of questions about what the course offers. There's a bunch of questions about personal questions. So where do I learn HLD from? What's the best domain of computer science to choose in the case of AI? Right? All these kind of questions. Right? It's scale for students or working professionals only. So folks, if you have any of these career related questions, if you have any of the career related questions, then unfortunately today's live class is not the right place. So we have a service for this. We have a free career counseling service. So my co-host, she has just launched a poll over here. So what happens in this service is you get on a call. So once you press yes in this poll, we will connect with you on a one-to-one call. It will be a short 15-minute call, completely free of cost, right? During that 15-minute of call, you will be asking us the questions. And we will be trying to answer your questions. You can ask us any career-related doubt. It has to be related to career, but apart from that, you can ask anything. Okay? So you can talk about job prospects. You can talk about how to get referrals. You can get your resume reviewed. You can talk about salary expectations. You can talk about if you have a career gap, how do you explain that? You can talk about that. If you need learning resources, you can talk about that. If you have any sort of personal questions that we cannot answer in this massive class, this class is one to many. If you cannot answer this in this class, then this is the right place, right? So just press yes in the poll. We will get in touch with you on a short 15-minute call. It will be one-on-one call. Okay. So with that, you can get your doubts answered. All right. Perfect. Awesome. In case you have missed this poll, don't worry. I will ask my co-host to launch this again after some time. All right. Cool. So let's start with the discussion of high-level design for a system called type. Cool. Now, when we begin this particular thing, the first thing that we should understand is what on earth is type ahead. If you go to the interview and the interviewer says design type ahead, right? So the interview comes and says design type ahead. All right, and you are Spooky. So Spooky is my cat, right? And Spooky is not very smart because he's a cat. So you can imagine if Spooky goes to the interview, he'll be very bewildered. He will not know what type ahead is. So what would Spooky say? If he goes to the interview, he will say, hey, I have never heard of type ahead. Can you explain what type ahead is? All right. And the interviewer might reply something like this. They might say that, okay, it's basically a search feature. When you type something in the search box, it tries to auto-complete your query. All right. So the interviewer tells you, type ahead is basically a search feature. When you type something in the search box, it tries to auto-complete your query. Now, the moment you hear this, your mind will start racing. You will start thinking of all the places you have seen autocomplete. Yes? So let's do this exercise. You guys tell me, at what all places have you seen autocomplete? So one person in the chat is saying, we have seen autocomplete in Google search engine. Yes? YouTube. Gmail. Where in Gmail? Where in Gmail? Someone is saying Google Keyboard, Visual Studio Code, WhatsApp, messaging, right? Mobile keyboard, Outlook, email, browser search bar, all of these places. Absolutely. So whenever you go to Google, right? If you go to Google, and so let me go to google.com and I start typing something in. If I say why is the, right? So this is trying to auto-complete my query. Do you guys see this? It is trying to auto-complete my query. If I go to Amazon.in and if I search for, let's say, cat food, then once again it tries to auto-complete my query. If I start searching for t-shirts, then once again it starts to auto-complete my query. Right? This is one place that we have seen autocomplete. But there are many other places as well. For example, when you're writing email, when you try to put the email address, it tries to autocomplete the email from your contact list. Yes, it tries to autocomplete that. Similarly, if you have used any AI assistance tool, if you have used ChatGPT, if you have used Gemini, and if you have used that in your code editor, then it tries to autocomplete your sentences. In your phone, when you type something in the keyboard tries to predict what word you are typing. Yes, all of these places are autocomplete. Are we supposed to build all of them? Are we supposed to build all of them because the interviewer has said autocomplete? No, we have some idea of what the problem is, but we need to dive deeper. We cannot possibly build all of them. We have to focus on what we are trying to build. So we can start reasoning by analogy. We can start telling all of this to the interviewer that, okay, I have seen autocomplete in these scenarios. I have seen it in YouTube, I have seen it in Amazon, I have seen it in these places. Can you pinpoint me to what kind of functionality are you looking for? Okay? So you can think and you can pitch it back to the interviewer. It's basically a game of tennis. The interviewer throws the ball, says design type ahead. You throw the ball back. You hit the ball back. I don't know what type ahead is. Can you please explain? They give you a brief explanation. So the ball is back in your court. Right? Then you hit it again. You give them once again. You do some thinking and then you give them an answer. Alright? So at this point, the interviewer might explain that okay, when you go to YouTube or when you go to Google, okay, when you go to Google, when you type something in, it tries to auto-complete your query. Right? So this system is type ahead. Similarly, when you go to Amazon, this is type ahead. Okay? In type ahead, the following thing happens. So once again, let's go to Google. And let's try it. Why is the? Right? Let's suppose we type this. The query that I have typed, this is a partial query. I have not completed my search yet. I am just typing something in. Okay? As I am typing in, the system tries to complete what I am trying to search. Yes, it tries to predict my search query. Is that part here? As I am trying to type the search query, the system tries to predict my search query. So it has given me all these predictions. Has a search happened yet? Has a search happened yet? Have I performed a Google search yet? Not so far. Once I click one of these queries, let's suppose I click on why is the sky blue? When I click this, then an actual search query happens. In this search query, I get this following search query over here at the top, and I get a bunch of search results. Yes. Similarly, if I go to Amazon, if I start typing for let's say t-shirts, then as I type, it tries to predict what I am about to search. Search has not happened yet, but when I click one suggestion, then an actual search happens. Okay? So if the interviewer tells you this, does this help you understand that type ahead is related to search? Type ahead is related to search. We have a bunch of other autocomplete features as well. In Google keyboard, in your mobile keyboard, there is autocomplete. But is that autocomplete related to search? Not really. In your code editor, when you're writing code, in Cursor or in VS Code, whatever, when you're writing code, it tries to auto-complete your code. Is it related to search? Not really. When you are writing an email, it tries to complete your email. Is that related to search? No. Those are other forms of autocomplete. Type ahead is an autocomplete system which is always associated with search. It's always a precursor to search. It comes before search. Does that make sense? Yes? No? So in a type ahead system, you type something, you get a bunch of suggestions. This is your partial query, this goes into the system, you get a bunch of suggestions. Once you click something, an actual search happens with your full search query and then you get a bunch of search results. Okay, this is what type ahead is. Once again, the difference between type ahead and autocomplete is that autocomplete can be for multiple purposes. Autocomplete can be for any purpose. Type ahead is a special form of autocomplete that always comes before some sort of search. Okay? So whatever you're trying to search, it tries to predict what you're trying to search. That's the purpose of type ahead. Right? They basically do the same thing. Yes. So there's a lot of autocomplete functionalities and they overlap. They are similar. But type ahead is especially related to search. Basically, all of these queries that you see, these are search queries. When you try typing something over here, it will not complete your code. Yes or no? If I go to Google and if I say, let's say void Fibonacci, right? It will not try to complete my code. If I put this in my code editor, it will try to auto-complete my code. But Google will not do that. Google will treat this like a search. Google will treat this like a search query. That's the main difference. Okay. Perfect. Yes. Type ahead is an autocomplete feature for search use case. Absolutely. Cool. So now we have understood what we are trying to build. We are trying to build type ahead. What are we not trying to build? We are not trying to build smartphone keyboards. We are not trying to build text editors or code editors. We are not trying to build Grammarly. We are not trying to build email autocompletion. Okay, we are trying to build search autocompletion. Alright? And to help you better understand, imagine the backend infrastructure of Google. When you perform this type ahead query inside Google, imagine the backend infrastructure. Inside Google, there might be a bunch of servers. Right? There might be a bunch of servers inside Google. These servers will be in different microservices. Do you guys understand the concept of microservices? Do you have some basic idea of microservices? For example, Google has multiple products. Google does Gmail, Google has YouTube, Google has Google Maps, Google has AI, Google has a ton of different products. If you enter a request for Gmail, let's suppose you're trying to send an email, should that request go to the YouTube service? No, right? If you're trying to send an email, it should go to the email service. It should not go to the YouTube service. So Google in the backend, they have separate services that handle different products. Okay. For example, they might have a search service. They might have a YouTube service or a video service. They might have an email service. Okay. They might have multiple services. Okay. So just like that, behind the scenes, Google might have a search service and they might have a type-in service. Both of these services will have its own set of servers. They will have their own databases. Okay, so the search service has a bunch of servers, they have a bunch of databases. The type-in service also has a bunch of servers and it has a bunch of databases. Okay, and the user is over here. So this is you. This is the user, you are over here. You get a search box. As you start typing, the front end starts sending requests to the backend. As you start typing, the front end starts sending requests to the backend. And I can demonstrate this actually. I can demonstrate this. Let me once again open google.com and let me open the network tab. You will see as I enter characters over here, for every character, you will see a new request coming up. So I will type, why is the? Do you see request coming up over here? Sky blue. As I type, you will see these searches. And these searches have this kind of thing. It says this. Right? Why is the? It says this. Okay? So as I'm typing, for every character that I type, an API request is sent to the backend. This API request goes to the type-in service. And the type-in service gives me back suggestions. It tries to complete what I have said. Once I do that, once I'm satisfied with the suggestions, I will click a suggestion and that will actually make a search. This request will not go to the type-in service, it will go to the search service. Okay, and then the search results will come. Is this distinction between type-in and search clear? Is the flow of data, flow of requests, and the distinction between type-in and search clear? They are interrelated. We will talk about what the interrelation is. But is the difference clear? Okay? Perfect. Okay. So now at this point, we have completed the step one. We have understood what the problem statement is. Let's move on to the next step. Okay? Let me repeat. Once again, the idea is that inside the backend of Google, inside Google's backend, inside the actual Google, there will be multiple services. Right? Services like Maps, services like Gmail, like YouTube. Some of these services will also be search and type-in. Okay? As you are typing your query in, the front end, your browser, will continuously make requests. For every character that you type, the browser will send a request to the backend. Right? It will contain your partial query. So when you're typing Y, the browser will send a request for Y. The moment you type I, it will send another request. When you type S, it will send another request. These all requests, they will go to the type-in service. Okay, all these requests go to the type-in service. And for every request, the type-in service will return a bunch of suggestions. And we will show these suggestions. Once the user actually clicks a suggestion, this will make a search query, which will go to the search service. Okay? Now the question is, yes, all of you have already started thinking, if we are going to make a new request for every character, there will be billions of requests. Yes or no? If we are going to make a request for every character, there will be billions of requests. And Google already has billions of users. So how are we going to scale the system? Isn't this going to be extremely difficult? That's exactly what we will discuss today. We will see how to build the system and how to scale it. How to build a system for billions of users across the world. That's what we will figure out today. Okay? Cool. Perfect. So this is the problem statement. Now, given that this is the problem statement, can we immediately start designing the solution? Now that we know what we are supposed to build, can we immediately start designing the solution? Unfortunately, not really. We cannot do that. Why can't we do that? Because we know what we are building, but we still don't know what the exact requirements are. Yes, we don't know who we are building this for. We don't know who the users are. We don't know what the exact requirements are. We don't know what scale we are building this for. So we have to first understand all of this thing. Okay? So let us understand this step by step. The first thing that we are going to do is we are going to collect the functional requirements. The functional requirements, okay? The functional requirements, basically they mean the functionality that you're offering to the actors, that you're offering to the clients, the actors or the users. Okay, so we are going to discuss what functionalities, what requirements are we offering to the user. Okay, and whenever I think of functional requirements, I like to think of the MVP, the minimal viable product. Are you guys familiar with this? Have you heard of this term, minimal viable product? So this term is very common if you hang around with startup people. If you have any friend who does startups or who visits conferences or things like that, then you might have heard this term, minimal viable product, right? Minimal viable product, it's like a proof of concept. It's like a proof of concept. It's the starting version of any product. For example, when Amazon started, when did Amazon start? It started way back in 1993, right? Nowadays, Amazon.com does a ton of things, right? They have the e-commerce website, they do AI, they have the AWS infrastructure, they have a ton of things. But back when Amazon started, do you think they had all these features? No, right? When Amazon started, they literally had one office. Inside that office, Jeff Bezos used to sit and he used to sell books online. Right? He used to sell books online. On the Amazon webpage, there would be a bunch of book information. And whenever you wanted to purchase a book, there would be a number, a phone number on the website. You would call that phone number and Jeff Bezos would pick up. And then you would manually order the book on the phone with Jeff Bezos. And then the book will be delivered to you. That's how Amazon.com worked initially. Right? So, in the MVP is basically the minimal viable product. What is a product? A product is something that solves a general problem for someone. Yes, that's what a product is. What is viable? Viable means that it should be able to demonstrate the core functionality. It should be usable. It should not break down. It will not have a bunch of fancy features, but it should be usable. And minimal means that you need the minimal set of features to demonstrate this core product. Okay? You should produce the minimal set of features to demonstrate this core product. For example, if you're trying to build a new car, what will be the MVP for the car? The MVP will be some sort of wooden board and 4 wheels attached to that wooden board. That will be the MVP. It will not even have an engine. But it will demonstrate the viability of transport. Yes, it will show you that yes, you can move around using this car. Fair enough? That's the MVP. The idea is to keep the features minimal. Yes, we should talk about the minimal set of features. Now you might say, why? When we are discussing the feature requirements, why should we limit ourselves to the minimal features? Who can tell me this? When we are discussing the feature requirements, why should we limit ourselves to the minimal set of features? Simplicity, time constraint, absolutely correct. Easier for making changes, to start out designing scope, avoid confusion, all of these things are correct. Right? All of these things are correct. See, you are working in a time environment. You have 45 minutes. In the 45 minutes, can you actually go ahead and design the entirety of Google? Do you think you can do that? Or do you think anyone in the world can do that? Right? Google has existed for almost 30 years at this point. Right? Google is a 30-year-old company, almost. It's like 28 years old. For the past 28 years, some of the most brilliant and some of the most smartest people in the world, they have worked together to build a Google infrastructure. Right? And they have taken 30 years, and it's not just one person. There's tens of thousands of developers working at Google. Do you think you can design the entirety of Google in one day? Or in 45 minutes interview? Absolutely not. So you have to focus. You have to focus on a small subset of the things that you can design. Fair enough? Secondly, if you try to talk about a lot of features, you will only be able to cover them on the surface level. Yes? If you have to talk about this as well, this as well, this as well, this as well, then you will not be able to deep dive. You will cover a bunch of this, a bunch of this, a bunch of this, a bunch of this. If you take only 2 features, then you will be able to deep dive into this as well and deep dive into this as well. Right? And deep diving during the interviews is important because that is what will impress the interviewer. Alright? If you only talk about things in the surface level, the interviewer will say, yeah, you just read a bunch of books. The interviewer will feel that you just watched a bunch of videos. Right? To showcase your actual skills, you have to deep dive. And for that, you are in a time constraint manner. Okay? That is why we need minimal features. Right? There's one question. In the MVP, should we not think of the edge cases and only think of the core functions? Absolutely right. We should only think of the core functions If the edge case is useful enough, only then can we think about it. Okay? If the edge case completely breaks the system, then we have to think about it. Otherwise, no. Fair enough? Cool. Security aspect is true, but we typically do not consider security aspects in the system designer. I'll tell you the reason why. Right? I'll tell you the reason. Security should not be discussed unless you are a security expert. Fair enough? Majority of the bugs that happen in software systems, the security issues that happen in software systems, they happen because non-security experts try to do security. Okay? So you should avoid security as much as possible. Okay. So let's try to think of the functional requirements for this type system. Now, whenever we think of the functional requirements, you should always start by understanding who is the end user of this product. Right? Who is the actor? Yes. For the case of timeline, it is simple. The actor there's just one actor. It is the end user. The end user is the person who is performing the Google search. Right? There is only one user in the system. Right? But it is not always as simple. For example, tomorrow you might go to a different company and they might ask you a different case study. They might ask you a different question. They might ask you to design Uber. In Uber, there are multiple actors. There's the drivers, there's the riders, and then there's the backend staff. Yes or no? In Amazon, there's customers, there's sellers, there's delivery partners, there's support staff. So it is not always the case that you only have one actor in the system. When you're building Uber, you have to think from the driver side as well and the rider side as well. You have to think from both the sides. Okay? But in case of timeline, it is simple. We just have to think of the end user. So when we come up with features, we should think of the user features. What features are we offering to the users? Alright? Fair enough? Okay. So what we are going to do now is we are going to start with this feature requirements gathering. Okay, we are going to gather the requirements. And for gathering the requirements, you guys will suggest me the features. In the chat, you guys will provide me what features do you think this system should have. Alright? Just keep in mind that you are supposed to keep your features minimal. If you feel that a feature is too fancy, in that case, avoid that feature. Okay? If you feel that a feature is too fancy, if you feel that a feature is not really needed right now, avoid that feature. So you guys tell me the features in the chat. A single word is not a feature. Saying a word like debouncing, that's not a feature. Input box is not a feature. A feature comes as a requirement. It should come as a complete sentence. Right? For example, one of the features in Uber could be that when the rider tries to book a ride, I'll give you an example feature. Right? Example feature for Uber. Right? The feature for Uber would be that when our customer requests a ride, match their request with the available nearby drivers. Okay, this is a feature requirement. I'm not saying matching.